Hello students, you are welcome to the Curriculum Studies in Physics module, and we are going to look at Unit 2 of this module. And in Unit 2, we are going to look at the determinants of the physics curriculum. In the first session under Unit 2, we will be looking at the learner as a determinant of the physics curriculum. My name is Patrick Eji. Now, at the end of this session, you should be able to explain the elements which interact to produce effective teaching and learning. Secondly, you should be able to explain why it is important to consider the learner when developing the physics curriculum. Now, let's look at the elements for effective teaching and learning. And basically, 4 elements are required in any effective teaching and learning situation. And these 4 elements are the teaching curriculum in the study area. And so here, the physics curriculum is one of the basic elements that is required for effective teaching and learning to take place. Secondly, there must be a learner to be taught. Then, the teacher who will now teach the content. And finally, the availability of teaching materials or facilities. Now, let's look at how these elements mentioned interact to produce effective teaching and learning. And looking at the diagram below, you realize we have the curriculum. So over here, the physics curriculum. We have the physics teacher. We have the learners or the students. And we also have the teaching learning materials. Now, this more or less resembles something like a Venn diagram. A Venn diagram. Now, you realize that the teacher interacts with the curriculum. And there is also the teacher who interacts with the learner, as well as the teaching learning materials. All these come together, and the central point over here, where the arrow is pointing, is showing that when all these 4 elements interact, we gain what we call effective teaching and learning. So these elements must work together in order to achieve effective teaching and learning in the physics classroom. Now, why must we consider the learner? So now let's look at the learner. Now, the physics curriculum is influenced greatly by the mental, the physical, and emotional requirements of the learner. So anytime we are designing the physics curriculum, we must consider the mental level, the cognitive level of the learner. We cannot just include any content at all in the physics curriculum to be given to learners to learn. And the physics curriculum planners look at the learner's level of development and maturity. So at every point in time, there is a content that must be given to the learner. So in year 1, there is a content for the learner. In year 2, there is a content, and in year 3, there is a content. The content are designed in such a way that they follow the maturity level of the learner. Now, the learner should be given what they can handle in terms of depth and quantity. So the fact that we are saying that the curriculum goals and objectives has to be, translated into learning experiences that will be acquired by the learners, also means that at every point in time, whatever content that is given to the learners should be able to understand them. They should be able to take them at that point. Now, in every educational program, there is a baseline and a ceiling. So when you compare your room to a baseline and a ceiling, then you realize that the baseline becomes the floor of the room, and the ceiling becomes the limit. So, like your ceiling in your room, that is the limit in the room. And so the baseline is a starting point. And this starting point assumes that students who are entering into the program have already acquired some basic knowledge and skills relevant to their understanding of the new content of the baseline. Now let's relate this to the physics syllabus we have been using. You realize that in year 1, we normally begin with scientific units and measurements. Then, from there, we continue with density, then relative density, and the rest. Now, you realize in junior high school, students are introduced to these units and measurements. And so when we start with them, they do not see it as new until we now start adding the relative density and the Archimedes principle and the rest, which they were not introduced to in the basic school. Now, the ceiling in the program refers to the maximum in terms of content quality and quantity that will qualify the learner as having acquired the desired knowledge and skills at the end of the program of study. So, what content must the learner take? So, when you look at you as a physics teacher, there are a number of content courses you must take in your major area to qualify you as a physics teacher. There are a number of courses that you will take, that is the educational courses or the pedagogical courses that you also have to take to qualify you as a teacher or a physics teacher. Now, you cannot just take only the content courses and then just come out and say that you are a physics teacher. Now, the baseline and the ceiling content are determined by the ultimate goals of the curriculum in terms of what task the learner is expected to perform at the end of completing the program. So after the learner has gone through the program, what the learner should be able to do is what will determine the starting point and the ending point of the program, or in other words, the baseline and the ceiling of the program. And so the student in the teaching learning process assumes the position of a benefiting end. So we all know that in the teaching learning process, it is the learner who is at the benefiting end, who is at the receiving end. Although the learner is at the receiving end, but without them, the development of the curriculum, the preparation of teachers, and the acquisition of the teaching learning materials will become meaningless. Now, assuming there are no students or there are no learners to be taught, after you go through your Earth Science program and now you become a physics teacher, the question is, who are you going to teach? There are no learners for you. You have the curriculum, you have the teaching learning materials, but there are no learners. And so, although they are the benefiting end, they are the receiving end. But they are very important when it comes to designing the curriculum. Now, for a successful completion of a study that will give a meaningful performance to the learners of the program, the following vital requirements must be met. And these are: the student has to be prepared to learn. And secondly, the teacher has to be knowledgeable in handling the curriculum. And the teacher's knowledge must be far above what is stipulated in the curriculum. And also, the teacher must use appropriate teaching methods in the teaching process. Now, in the previous sessions, we saw that when it comes to teaching methodologies, there is no single best teaching methodology that enhances students' learning. And so you as a teacher must employ the appropriate teaching methodologies that will enhance students' learning. And then you also use appropriate teaching materials that are available to you. The teaching materials must always be appropriate. For instance, you are teaching science, let's say, mass of a body, but the instrument available to you is a thermometer. You realize, yes, you have this teaching learning material, but it is not appropriate to the content that you want to teach. Students, this will bring us to the end of the session. And in this session, we look at the learner as a determinant of the physics curriculum. And we also find out or explore why we must consider the learner in designing the physics curriculum. Now, as we end the session, let's take this question. With respect to educational programs, what is the difference between the baseline and the ceiling of a curriculum content? Think through to have an answer to this, and I will take the answer in our subsequent session. Thank you for your time.